Question 201. How would you integrate a Kotlin project with continuous integration, continuous deployment, CI/CD pipelines, and what tools or services would you use? I would integrate a Kotlin project with CI/CD pipelines using tools like Jenkins, Travis C, or GitLab CI/CD. By automating the build, test, and deployment processes, I can ensure faster feedback loops, improved code quality, and seamless delivery of features to production. Question 202. Can you explain the advantages of using dependency injection frameworks like Kotlin or Dagger in Kotlin applications, and how would you choose between them? Dependency injection frameworks like Kotlin and Dagger help manage object dependencies, promote modularity, and facilitate testing in Kotlin applications. Kotlin is lightweight and easy to use, while Dagger offers compile-time validation and performance optimizations, making the choice dependent on project requirements. Question 203. How would you troubleshoot a performance issue in a Kotlin microservice running in a cloud environment, and what tools or techniques would you use? To troubleshoot a performance issue in a Kotlin microservice on the cloud, I would analyze metrics from monitoring tools like Prometheus or Grafana, profile the application using tools like JProfiler, and use distributed tracing tools like Jaeger to identify bottlenecks and optimize code accordingly. Question 204. What considerations would you take into account when designing a scalable and resilient microservices architecture in Kotlin, especially in a cloud-native environment? When designing a microservices architecture in Kotlin for the cloud, I would consider factors like service discovery, load balancing, fault tolerance, and distributed tracing. I would use technologies like Kubernetes, Istio, and Resilience4j to ensure scalability, resilience, and observability in the system. Question 205. How would you ensure data consistency and durability in a distributed system built with Kotlin? And what strategies would you employ to handle failures? In a distributed system built with Kotlin, I would ensure data consistency and durability by using techniques like event sourcing, distributed transactions, and idempotent operations. I would implement circuit breakers, retries, and fallback mechanisms to handle failures gracefully and maintain system integrity. Question 206. Can you describe a situation where you had to optimize a Kotlin application for memory efficiency, and what techniques did you use to achieve this? In a previous project, I optimized a Kotlin application for memory efficiency by minimizing object creation, using primitive types instead of objects, implementing lazy loading, and tuning data structures for reduced memory footprint. These techniques helped improve performance and scalability without sacrificing functionality. Question 207. How do you ensure secure coding practices in your Kotlin projects, especially when handling sensitive data or interacting with external APIs? To ensure secure coding practices in Kotlin projects, I follow principles like validating input data, sanitizing user inputs, using encryption for sensitive data, avoiding hard-coded secrets, and implementing proper authentication and authorization mechanisms. I also stay updated on security best practices and vulnerabilities to mitigate risks proactively. Question 208. How would you approach the task of migrating a legacy Java codebase to Kotlin, and what challenges or considerations would you need to address during the migration process? When migrating a legacy Java codebase to Kotlin, I would start by converting small modules or classes gradually, ensuring backward compatibility, maintaining test coverage, and refactoring as needed to leverage Kotlin's features effectively. I would address challenges like interoperability, tooling support, and team training to ensure a smooth transition. Question 209. Can you explain the differences between Kotlin's data classes and regular classes, and when would you choose to use each in your code? Kotlin's data classes are designed for holding data and automatically provide implementations for equals, hashcode, and two-string methods, making them ideal for modeling immutable data objects. Regular classes, on the other hand, are more flexible and suitable for classes with behavior or stateful operations. Question 210. How would you design a secure authentication and authorization system for a Kotlin web application? And what best practices would you follow to prevent common security vulnerabilities? To design a secure authentication and authorization system in a Kotlin web application, I would use technologies like OAuth, JWT, or OpenID Connect for authentication, implement role-based access control, enforce HTTPS, sanitize inputs, avoid SQL injection, and protect against cross-site scripting, XSS, and cross-site request forgery, CSRF attacks. Welcome to CloudRoar CSPM, your intelligent cloud security posture management platform. In today's hybrid and multi-cloud world, maintaining visibility and control across AWS, Azure, and Google Cloud can be complex. CloudRoar CSPM simplifies that by continuously scanning all your cloud accounts, configurations, and workloads. Our platform automatically detects misconfigurations, compliance violations, and potential security risks before they become incidents. CloudRoar CSPM provides clear, actionable insights mapped to major frameworks like CIS, NIST, and ISO standards, helping your teams remediate faster and stay audit-ready at all times. Strengthen your security posture, achieve continuous compliance, and take control of your multi-cloud environment with CloudRoar CSPM, security that's smart, scalable, and proactive. Introducing CloudRoar Cost Optimization, your unified platform for smarter cloud spending across AWS, Azure, and Google Cloud. Cloud costs can grow silently, but CloudRoar gives you full visibility and control. Our engine continuously analyzes usage patterns, instance sizing, and idle resources to uncover hidden savings. With intelligent recommendations powered by real-time data, CloudRoar helps you right-size resources, eliminate waste, and maximize return on every dollar spent in the cloud. Get detailed reports, actionable cost insights, and automation that ensures continuous optimization without compromising performance. Optimize confidently, scale efficiently, and make every cloud dollar count with CloudRoar Cost Optimization. Efficiency meets intelligence. Welcome to CloudRoar CSPM, your intelligent cloud security posture management platform. In today's hybrid and multi-cloud world, maintaining visibility and control across AWS, Azure, and Google Cloud can be complex. CloudRoar CSPM simplifies that by continuously scanning all your cloud accounts, configurations, and workloads. Our platform automatically detects misconfigurations, compliance violations, and potential security risks before they become incidents. CloudRoar CSPM provides clear, actionable insights mapped to major frameworks like CIS, NIST, and ISO standards, helping your teams remediate faster and stay audit-ready at all times. Strengthen your security posture, achieve continuous compliance, and take control of your multi-cloud environment with CloudRoar CSPM, security that's smart, scalable, and proactive.